So you are familiar with this curve. Is a Z curve that you remember. Z curve, what like has positive values for Z. We have positive values for Z. We have negative values here. So what we do with this curve, for any Z value, we just go in this table and we can read the area on the right of that Z value. The same thing for the left Z, for the negative values of the Z, for each Z, we go to this table and we can go read the area on the, the area on the left of the Z. The same thing here, the area on the left. Then we work on the T table. So in T table, we had degree of freedom and confidence level or significance level alpha. This confidence level is 1 minus alpha, that we call it confidence level. Alpha itself is called significance level. So we are going to work with it a little bit later in this slide. So you remember that we had to calculate the t value, and then we had alpha. We were coming to this table and finding the t from this table. And if the t that we were calculating was, let's say, in this range, in the blue range, it was somewhere like here or here, then we were rejecting the null hypothesis. Okay, so this is one example that you already work on it. I think you have also some YouTube videos in your slides. You can watch them. Then yeah, like we had, that was for two-tail, that we were going to use the two-tail, this row here. For one-tail, we have also a table like this. So we already used that. So in this video, I'm going to use Z table, and we have also new table that we call it F table. So let's see what we have to do. Okay, I'm not going to go through the details of what I have, what is written here, because it might be a bit complicated for you. But I'm gonna just, I'm just gonna leave this slide for you. It's some additional information that you can just read them. So p value or p approach is something similar to t-test, the pooled t-test that we already used, with some small differences. And I prefer to use some examples for you. In that case, it's easier for you to understand this method. Otherwise, these explanations are kind of just for you to read them. But if you need some additional explanation, you can ask your question, and I will be happy to answer. So it's just a method, is a critical value approach, like T approach, T test. We have also P value of P test. So we use the same equations that we have. So what we do here, we have to calculate again a parameter like T. So you remember, like we will see this, what are these parameters in one example that we have. So we consider our null hypothesis, we calculate T, and then we go like based on the level of the confidence that we go find our t, then compare this t with the t that we find from table, and if it's in the shaded area, we will reject the null hypothesis. If it's out of that shaded area, we will accept the null hypothesis. So for p value, we will follow the same method. So we have again two-tail, left tail, right tail. All the explanations are here, but as I said, it might be a bit confusing for you, and I prefer to just show this in some examples, that what we have to do exactly for a p-value test, which is very similar to the pool t-test that I already solved one question for you. So okay, so what we do here for the first step, we have to, we will write our null hypothesis and then alternative hypothesis. If it's not, for a non-equal, we have two-tail. For if the first mean is bigger than second mean, we have we have right tail, and if the first mean is smaller than the second mean, we have left tail. So what we do, we calculate t at the beginning, then we have the level, the significance level alpha. We go find the t from the for this alpha and the degree of freedom that we have. We go find the t value, and that is the t value that you will find from the table. Then you also calculate one t by using equation, this equation that we have. So if that t that you calculate is somewhere here in the shaded area, so you will reject your null hypothesis. Okay, for the two tail. For the left tail, if your t is somewhere here, and for the right tail, if your t is somewhere here. In all those cases, you will reject your null hypothesis. Otherwise, you will accept it. So in the p-value, what we do, we don't go read the t table. We go read from z table. Okay, this is for p-value test. We don't go to the t table. We don't go to t table. We go to the z table. That's the only difference, the main difference between p-value test and t-test. Okay, so in t-test we go to the t table. In p-value test we go to the z table. So now let's see what we have to do. I'm gonna start with some examples. So p-value here is nothing more than the kind of the z value. Okay, so let's look at this example. Obtaining p-value for a poor t-test. So I'm gonna start with first example. In a left tail test, the test static value is t is this, and t is here -1. Assume degree of freedom 50. Calculate the p-value in each case. So here p-value is nothing more than the area. It's very straightforward. P-value here is nothing more than this area here. Okay, so what we have to do, we have the degree of freedom. All right, so for part 1 I have degree of freedom 50, and for part A, this is question 1, part A, I have t minus 1.872 and is also left tail. So left tail is here, somewhere here. So I have this is my figure, left tail. So this is my 0. This is the value that I have, minus 1.852. So since is left, I have to find this area here. This area here, it gives me my p value. So how we can find this area? We have this t here, okay? We have this t here, and we have to find the area. So let's go look in t table. Okay, for degree of freedom 50, unfortunately we don't have, okay, we don't have the 50 here, so is a bit difficult to find it from here because we don't have I'm talking about this part 50 here, we don't have it, so we cannot easily find the area here, area on the left. And Okay, so let me see, maybe I can find some other values here. Okay, just give me 1 second. Okay, t bigger than 50. Okay. So we cannot use the t table. We have to go through the z table. Okay, z table, my t is negative, so it's minus 1 point something. So I can go look at this table. So I need to find the area on the left. Okay, on the left of my t. So my t is how much? I have it here. 1.852 minus 1.852 minus 1.852. So in this case, help me to find it. So minus 1.8 is here, 0.5 is here, minus 8 is here. Just go all the way, and this is 0.5. So that will be my area. That will be this area here, the area on the left. So that is my z value, that is my p value, the area that I will find, which is 0.0322. So the answer here, p value is 0.0322. This is how we find it. So you can use this, you can use another value. I mean, you can use this t value and then again calculate the p value by using the table. And you can also do it with two tails. For two tails is also similar. So in two tails, what you have to do, I already solved one similar question. So two tail, for example, for part A, so this is your z, t is given minus 1.66. Since it's a symmetric for two tail, so the other part will be positive 1.66. So what you can do, p value now is this area plus this area, all this area, these two area together, that is my p value here. So for this question here, so all these two area, these two shaded area is my p value. So what you can do, you can go to the z table for this t, for this z value, you can find the area on the left. Okay, since it's symmetric, that area is also equal to this area. So you just need to go to the z table and find this area, and this area multiplied by 2 gives you the p value in this case. You can also do it for this example. But for now, yeah. So z table in general, this is the general method that we use to find p-value in this case. But we have another example that is more important. I'm going to talk a little about it. I'm going to talk about it a little bit now. But just let me to go back to t-table again. Okay. 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 So, but in general, for one point here, for degree high degree of freedom. Okay, don't forget that. If degree of freedom is large, the value the z and t value, they are very similar. You see that the maximum z that we have is how much? Minus 3,4. For the positive is 3,4, something like that. This is the maximum z. So while in t-table, if you look at t-table, at very high degree of freedom, somewhere here, you can see that my t values are all almost, the maximum t that I have is 3.6, 3.7, something like that, okay, 3.5. But while if the degree of freedom decrease, we have much more bigger t. So that means this curve here becomes much narrow. It becomes something like that. At low degree of freedom, it becomes something like that. Very low. I mean, very narrow curve. So now this is not good. But yeah, this is for the very high degree of freedom. This is for very low degree of freedom. Anyways, I cannot plot it nicely here, so let me try maybe here. Yeah, here is easier because I have to write here on the photo. So this is for very a large degree of freedom. This is for very a small degree of freedom, so that it continues in the walls. Even this is not ideal. I will try to explain later.